All right, so this is the beginning of Unit 8, which is all about logarithms. And our focus today, as I said, is just to look at what is a logarithm, how do we rewrite it in a way that makes sense for us, and then what are some really basic properties. So our goal for today is just basic properties of logarithms. All right, so if we go back to what a logarithm is and the whole point of it, and I kind of mentioned this a minute ago, but we have, if I ask you to solve something like 7.2 to the x power equals 175. We don't know how to do that other than guess and check right now, but the importance of a logarithm is that it is the inverse of an exponential function. So a logarithm, and this is what makes a logarithm so powerful, is the inverse of an exponential function. Again, what makes that important is that it gives us a way to solve an exponential equation without having to guess and check and without having to look at the graph. We can use a logarithm to actually figure out what that exponent should be. So I want to give you the conversion. And again, if you took Algebra 2 here, I think all the Algebra 2 classes talk about this, but this is really the most important thing when it comes to logarithms, is that you can go from a logarithm to an exponential function. So some things to look at there. The base of the logarithm, so that's b, is the same as the base of your exponential function, right? B is the base in both of those places. Here's the thing about logarithms, that if you can remember this sentence, makes rewriting them very easy. Your logarithm is always equal to an exponent. So the logarithm itself is always equal to an exponent. And you can see that because what we have here, what our logarithm is equal to, becomes the exponent in our exponential rewrite. So I like to write that down just because I think it's a nice little phrase to remember. So a logarithm is equal to an exponent. All right, so what that logarithm is equal to will be the exponent in the rewrite. Before we get into practicing with rewriting and all of that kind of stuff, there's two special logarithms. And again, I don't know how much of this you talked about last year, so I'm kind of assuming that you don't know any of this. Two special logarithms. If I can actually spell the word special. Wow, that was terrible. I don't know if you all saw that, but I was trying to spell special with the A coming first. The first one is what we call a common logarithm. So a common logarithm will look like this. Log of, let's say, 5. What that implies is the log that has a base of 10 of 5. So if the logarithm has a base of 10, you do not write the base. On your calculator, on the keys on your calculator, if you look at just the keys, not any of the menu items, the keys on the calculator, you'll just see log of x. Doesn't have a base written. Your calculators up until recently have only been able to directly find a logarithm's value only if it had a base of 10. Now, in recent years, you have new software, the technology keeps getting better and better and better. And now, for most of you, depending on the calculator that you use, you can actually choose any base you want. But if we're just looking at strictly a scientific calculator without any special menus, the only logarithm that it's capable of doing is a logarithm with a base of 10. So if you have a base of 10, you don't write it. It's called a common logarithm. This is the proper way to write it, what I've written here, this log of 5. That's how you'll see it written. The second special logarithm is what we call a natural logarithm. So a natural logarithm will look like this. It'll be ln, and then let's just say of x. We'll just use a random variable here. Now, in mathematics, you have to understand not everything directly correlates nicely to our English language, because it wasn't always, the Americans and English that figured out these properties. So when we talk about a natural logarithm, we abbreviate it with ln. You might think it should be the other way around, but I think it says logarithm natural in that order. But what that means is that it is a logarithm with a base of e. That's what a natural logarithm means. Now, how many of you have heard of the letter or number e before? Yeah, so a handful of you. A little bit. I don't expect you to be like totally proficient on what it is, but if you understand that pi is just a representation of a special number in mathematics, e is a representation of a special number in mathematics as well. E is just the approximation, and if we get into the development of this later, if we have time, we can, but it's approximately 2.718. Okay, there's no real other thing that you need to know right now about e, except that it's just a number. It's just a placeholder for a number. So again, the way we'll see the natural logarithm written properly is ln, and then whatever we're taking the logarithm of. So we have two special logarithms. Those are important for when we encounter those later on. So let's talk about how we can do some of this. So our first example is going to just be, let's rewrite each logarithm as an exponent. So we're going to rewrite each logarithm as an exponent. I'm going to abbreviate logarithms most of the time as just log. It's just a little bit easier. All right, so let's take something like this. So the log base 3 of 9 equals x. Now, I want you to hear how I said that, right? It's the log base 3 of 9 equals x. So when you read a logarithm, that's how you read it. Log base 3 of 9 equals x. Okay, so what I want to do is I want to rewrite that in exponential form. Let me just put our little cheat sheet here. You guys have this. You don't have to rewrite it. I'm just putting it here so I don't have to keep going up and down on my screen. So we know that our rewrite is the log base b of a equals c becomes b to the c power equals a. So the first thing I identify whenever I'm rewriting is what is my base. Okay, so in this case, my base is 3. So when I rewrite it, I'm going to have a base of 3 in my exponential function. Now, a minute ago, I said that one of the most important phrases to remember is that a logarithm is always equal to an exponent, which means that what the logarithm is equal to is my exponent. So this will become my exponent on b, and I'll just put here exponent. So 3 to the x power. And then whatever's left is what your exponential function has to be equal to. So 3 to the x power equals 9. Now, if I gave you that and asked you to tell me, initially if I said, tell me what the log base 3 of 9 is, you probably wouldn't be able to do it. But now if I gave you, tell me what x would be so that 3 to the x power equals 9, you could tell me that x would be 2. So just by rewriting it, sometimes it becomes a little more clear what is being asked. Okay, let's try, let's do the log of x equals 2. So the log of x equals 2. Notice no base is written. So I don't say a base. I just say the log of x equals 2. What that means, though, I want you to think about it remember, this is going to be our common log because there's no base written. So this is the same thing as saying log base 10 of x equals 2. And I think it's important that you think about what this common logarithm means before you try to go rewrite it. Because the first thing you have to know is what's the base of your exponent. And that comes from the base of your logarithm. So the base of my logarithm is 10. That means that's going to be what the base of my exponent is. So it's 10. And then a logarithm is always equal to an exponent. So my exponent in this logarithm is 2. So it's 10 to the second power equals whatever x is. So again, if I gave you the logarithm, log base 10 of x equals 2, and I asked you to tell me what x would be, you probably wouldn't be able to do it. But now that I've rewritten it, 10 to the second power is x. Well, that's easy. That means that x is 100. So just by rewriting it, sometimes it can illuminate a little bit better what you're being asked to find. All right, second thing we're going to do here is we're going to go the other direction. So rewrite each exponent as a logarithm. So we're just reversing. We're going from exponent to logarithm instead of vice versa. So the first one we're going to rewrite is 5 squared. And again, I'll just put this up here so we have it nearby and I don't have to keep pushing the screen up and down, but you have that on your paper, so you don't need to rewrite that every time. All right, so I have the exponent. I have the right side of that relationship. I know that my base of my exponent is 5. That means that the base of my logarithm has to be 5. So when I rewrite this, I start out by writing logarithm, so just log, of whatever, use the base first. So whatever the base is in your exponent is the same as the base of your logarithm. So it's going to have a base of 5. Then a minute ago, and I've said this a few times already, a logarithm is always equal to an exponent. So whatever this logarithm is equal to, it's going to be the exponent from my exponential expression. So the log base 5 of something equals 2. Well, the only thing left that we haven't used is x. And you can use that same relationship that we talked about up here, this guy, the log base b of a equals c is equal to b to the c power equals a. You can use that to help you rewrite, but just understand that, you're trying to put the pieces in place. You're trying to go from one form to the other. In the exponential form, it's a little bit easier to see what's happening. I could tell you that x would be 25, but I want to just get us in the habit of being able to go from one form to the other. Okay, so let's do this one. Let's do e to the x equals 15. Again, I want to rewrite this from exponential form into logarithmic form. E is just a number. We're just going to use it to hold the place of 2.718. But we can rewrite this. So the first thing I do is I think, okay, I'm going to write a logarithm. So log with a base of e, because that's the base of my exponential expression. My logarithm is always equal to an exponent, so that would be x, because that's the exponent. And then whatever's left is what we're taking the logarithm of. Now this is a log with the base of e. This is one of our special logarithms. So this is a natural log. So we want to rewrite it in that form. Okay, so when we see a log with a base of e, we want to rewrite it as a natural log of 15 equals x. So that natural log takes the place of the log with a base of e, right? That's what we're replacing. The 15 doesn't get replaced, the x doesn't get replaced. It's just the logarithm base e. That's what we're replacing. And that's because it's a special logarithm. It's a common log. All right. Questions so far? We've got 4 properties I want to talk about. Now, in Algebra 2, you would have taken the time to develop these properties. We're going to kind of start with what the properties say I'm just going to leave one piece out, and we're going to figure out that missing piece. So these are some basic properties of logarithms. So what we've talked about so far is just what is a logarithm, how do you rewrite it into an exponential function. These are some basic properties. And if you know what these properties say and you can remember what these properties say, it makes some simplifications a little bit easier, but it's not 100% necessary that you memorize these properties. And you'll see that in just a minute because we're going to go through how to figure out what these are, and you can repeat that process. So our first basic property starts like this. It says the log with a base of a, so that just means any base I want. Log of any base of 1 is equal to something. So a logarithm with any base of 1 equals something. Now what I'm going to do here is think about what that says if I rewrite it as an exponent. So if I were to rewrite this, okay, I would have a as my base. I would have a, remember, I'm going to use a little question mark to hold this space here, a to some power, because our logarithm is equal to a power, has to be 1. Anything raised to some power equals 1. What does that power have to be? Close. 0. If we raise it to 1, if we do a to the first power, that's going to give us a, right? Hold that thought because we're coming back to that in just a second. But anything raised to the 0 power is always going to be 1. So our question mark has to be 3. So our first basic our question mark has to be 0, sorry. Our first basic power is that, first basic property is that when you see a logarithm of any base of 1, it's always going to have a value of 0. Okay, that's our first property. So our second property, let's talk about this one. So now I have log base a of a equals something. Again, I'm going to think of that something as just being a question mark for a minute because we're going to fill in the blank here. So rewrite it. I think if you're having trouble, and here's the thing, no matter what, you can always try to rewrite. So if you forget what these properties are, try rewriting it and see if it helps. So if I rewrite this, the base of my logarithm is a. That's the base of my exponential expression. A to some power, because our logarithm is always equal to an exponent, will be equal to a. Now, what power of a gives me a? 1, right? So this time my question mark would be 1. So anytime you see the base of your logarithm equal to the thing that you're taking the logarithm of, your expression is always going to be equal to 1. Your logarithm will always have a value of 1. And again, you don't have to necessarily memorize these. They're nice properties to know, but you can always do a rewrite if you forget what the properties are. So let's do 2 more. We have 2 more properties here. Log base a of a to the x power. So here's the thing about logarithms. I can take the logarithm of anything I want with one exception, and we'll talk about what that is in just a minute. So it could be an expression, it can be a number, it can be a fraction, it can be just a bunch of letters, it doesn't matter. That means that I can take the logarithm of something that is a number raised to a power. So let's think about what that would look like if I rewrote it. Again, let me hold this with a question mark. So if I rewrite this, I would have my base of a equals something, that's my question mark, that's my logarithm, it's equal to a question mark, or it's equal to the exponent, will be equal to a to the x. So just by rewriting it, what does x have to, or what does the question mark have to be? In order for a to some power to be equal to a to the x power, what does the question mark have to be? X, yeah, right? It has to be whatever x is. So I could think of this question mark, it's always going to be x. Whatever x is in that expression. So if I said the log base 2 of 2 to the x, your logarithm is going to be x. If I said the log base a of a squared, then that's going to be equal to 2. Whatever x is, that's what your logarithm will be equal to. All right, and then one more property. Okay, this one's a little bit interesting. So it's a raised to the power of a logarithm. It's like logarithm and exponent inception. Okay, we've got a logarithm within an exponent. It gets a little tricky. We want to figure out what is this equal to. And again, I want to take a rewrite to try to help myself determine what's going on here. The key here is that our expression is actually at its most basic an exponent, right? It's something raised to a power. It just so happens that that power is a logarithm. That can happen. Our powers can be whatever we want as well. So how do I figure out what that's going to be? Let's rewrite this from an exponent into a logarithm. So now we're talking about going from an exponential expression into a logarithm. So the base of my exponent is a. That means when I write my logarithm, it will have a base of a. Now we have said that a logarithm is always equal to an exponent. So whatever this logarithm is, it has to be equal to an exponent. Well, in this case, the exponent is this entire expression, log base a of x. What would go here? What goes in that spot where the question mark is? In order for those two things to be equal, what does the question mark have to be? X. Yes. Now, again, if you can't remember the properties, that's okay. You can at least try to rewrite, and sometimes just with the rewrite, you can start to put things in place. But let's try to see if we can use some of these properties to maybe do a few quick rewrites. So I believe this is example 3. Yeah. Okay. So let's say I gave you the natural log of 1. So let me give you some instructions here. We're going to evaluate each of the following. Now, I may throw in some that use properties. I may throw in some that you just need to think about rewriting. So essentially what I'm saying is this is going to be equal to something. What is that something? Now, if you don't remember what all the properties say, we could rewrite this. This is really saying log base e of 1 equals something. It is 0, right? So there's two ways we can think about that. It's either using that very first property we talked about just a moment ago. A logarithm with any base of 1 is always equal to 0. If you don't remember that, if you rewrite this, you're going to get e is your base, your exponent will be what you're trying to find, equals 1. And then in that case, you should be able to hopefully recognize that you're raising something to some power and getting 1. That means that it has to be 0. So our natural log of 1 is 0. I could say the log base 3 of 1 equals 0. Any logarithm that we're finding a value of 1 inside the logarithm is always going to have a 0. Okay, let's do a few more here because I want to mix this up and use some that use the properties and some that don't. So B. How about log base 3 of 81? So log base 3 of 81. I want to find out what this is. Lots of ways you could go about doing this. I think probably the easiest way to do would be to rewrite it. I don't think any of our properties address this specific situation. So let's just rewrite. All right, so if we rewrite that, we have to rewrite it from logarithmic form into exponential form. That's our goal. the base of our logarithm is 3. That's the base of my exponent. A logarithm is always equal to an exponent. So we have 3 to some power equals 81. So really what I'm asking you to figure out is what power of 3 gives me 81? Might have to think about that one for a second, huh? 4. Yeah, good. So 3 times 3 times 3 times 3 is going to be 81. So that is equal to 4. We'll do a couple more here. I just want to get us comfortable with evaluating some logarithms. So what if I give you log of 100? All right, it's a logarithm without a base written. What does that mean our base is? 10. Yes, this is a common log. So you want to think about this as a common log. So think of it as the log base 10 of 100 equals something. We're trying to figure out what is that something. So if we think about it with a base of 10, then maybe try to rewrite it and see where that leads us. So what if we rewrite, instead of as a logarithm, write it as an exponent? So what we do is we find the base of our logarithm, which is 10. Logarithms are always equal to an exponent, so we're saying 10 to some power equals 100. What would that power have to be? 2. So this guy is just equal to 2. So by rewriting it, it gives us the opportunity to think about it in a form that maybe makes a little more sense. Okay, what if we do this one? Let's make it sort of interesting here. Log with a base of square root of 7 of the square root of 7 equals what? It's equal to 1. Yeah, so you could use either one of your properties that we talked about or rewrite it. But our question mark in this case ends up being 1. And here's what we're doing. You can think of a logarithm like this. This is kind of what I do in my head when I'm looking at a logarithm. Square root of 7, so this number, raised to some power will give me this. So the square root of 7 raised to some power gives me this. And the only way that's going to happen is if my power is 1. Okay, one more quick example, and this time I'm going to have you solving an equation. And it's going to seem like maybe I'm asking you to do something crazy, but it's not too bad. So this is the last example here. So solve the equation for x. So my equation is going to be this. The log base 4 of 2x plus 1. So we're doing a logarithm of an expression now. Equals the log base 4 of 3x. So the first thing that we should notice about this, and what's really important for us to know before we can do anything else, is that the bases of both logarithms are the same. So note, both logs have the same base. That is really important. If they didn't have the same base, there would be nothing we would do with this. Okay, we couldn't really move forward. But because they have the same base, what I'm saying is we have one logarithm set equal to another logarithm. Bases are the same. So what do you think has to be true about what we're taking the logarithm of? So what has to be true about 2x plus 1 and 3x in order for these logarithms to have the same value? They have to be equal, right? So these two things have to be equal or have to be the same, however you want to write it. this have to be equal? Well, that gives us a really easy way to set up an equation that I should be able to solve pretty easily here. So what I can do is I can say, all right, well, then 2x plus 1 has to be equal to 3x. That's an easy equation. It's just a linear equation. Subtract 2x from both sides, and I get x equals 1. A few minutes ago, I said you can take the logarithm of whatever you want with the exception of one thing. That one thing is that we cannot take the logarithm of something that's negative. So whatever's in here and here, these can't be negative. And I'll let you kind of think about why that might be. Okay, I'm not going to talk about why that is today, but we may address that a little bit later. So I would want to just make sure if I plug in 1 into the original expression, I want to make sure I don't get something that's negative. Right? If I plug in 1 here, I get 3. If I plug in 1 here, I get 3. We're good. But I have to make sure of that before I say, then my solution is 1.